Hey everybody, Mr. Zimbrick here. Today we are talking about the properties of water, our essential molecule of life. Our essential question today is going to be how do polar covalent bonds and hydrogen bonds lead to observable physical properties in water? Yesterday, or the last lesson, we talked about different kinds of bonds, ionic and covalent. We're going to be expanding on that today, learning about a new one called hydrogen bonds, and in particular, we're going to learn about hydrogen bonds in water. So without any further ado, what is water? That's our first question. And what images come to mind when you think of water? Maybe it's a serene lake or ocean, something like this. Maybe it's a tasty glass of water like this one. But today we're going to start thinking about water as something a little bit different. We're going to talk about some of the properties of water, like how can you fit so much sugar into Kool-Aid. There is a distinct property of water that we're going to talk about here that will tell us about that. We're going to figure out how does water strider like this stay on top of the water. Also has a specific chemical reason. And then we're also going to learn about why water pools up into droplets like this on a leaf. All of these you should be able to answer by the end of this lesson. All right, so we thought about what images come to mind when a chemist thinks of water, or when you think of water. What does a chemist think about water? Probably something a little bit different, and it might look something like this. Chemists think of water as H2O. In this case, we have oxygen bonded to two hydrogens, and we have this special little symbol right here with a negative and a positive. And we will be talking about those in just a minute. And it turns out that they're pretty important because those pluses and minuses end up influencing how water molecules interact with each other. And today we are going to be thinking like chemists when we think of water. All right, I'm also going to be going through a Cornell note example right here. So I've got the learning intention written up, and then we are going to do the 2/3, 1/3 columns. So 2/3 of your page should be for notes, and then a third or maybe a little less will be for questions that you're going to ask as we go. The idea here is that by the end of the quarter, you'll be writing down your own questions, but today I'm going to guide you through and put down some questions that maybe you are going to ask, or if you don't have any, at least you'll be able to write some down. To start with here today, we're going to talk about covalent bonds again and the lovely octet rule that we talked about last time. So we know water is a molecule. It's multiple elements bonded together. And when elements share electrons, such as in this water molecule, we call it a covalent bond. And we talked about this in the last lecture, but oxygen has 6 electrons in its valence shell, and it's looking to fill it up with 2 more. And it creates one bond with hydrogen here, and then another bond with hydrogen here. And now we have 8 electrons all in this valence shell right here. And those are covalent bonds. Oxygen now has its valence shell full, and hydrogen also has a full valence shell, and they're very happy by sharing. Turns out that something a little bit interesting happens when this bond occurs, though. Gonna get this out of the way. So when covalent bonds are formed, sometimes one element is a little bit more hungry for the electrons than the other, and it will pull the electrons a little bit more towards itself, or the electrons might be more likely to be found around it. It creates something we call polarity, which is an unequal distribution of charge. And these little symbols that I mentioned above our elements right here, this delta minus, delta plus, those indicate a partial negative or partial positive charge. So in this case, oxygen is more hungry for those electrons, so they're going to be more likely to be near oxygen than they are hydrogen, which means oxygen is going to be a little bit more negative than the hydrogen atoms are. So since they're a little bit more devoid, they're lacking an electrical charge, they have a positive charge. And we call this unequal distribution of charges polarity. So remember that, it's going to be an important concept moving forward. Okay, at this point what you can do is pause the video. I wrote down a main heading here in the notes. Water is H2O. It's an oxygen sharing 2 covalent bonds with 2 hydrogen atoms. And it's also a polar molecule, meaning that the electrons are not shared equally. And the questions I thought of first was, why does polarity matter? Why do we care about it? What effects does this have on other molecules around water? Those are 2 questions that you could write down at this point. All right, so going into a little more detail here about polarity. Since polar molecules have partial and negative charges, they will attract. Remember, opposites attract, just like magnets, just like just like the saying goes, opposites attract. It's also true in chemistry. And in this case, our opposites are going to be the negative oxygen atom and the positive hydrogen atom. And what happens is that when lots of water molecules are around each other, the positive atom with this partial positive charge right here from the hydrogen is going to want to be closer, or it's going to form a little bit of an electrostatic bond with this oxygen atom. So that means that they're going to want to link up and kind of stay close together. And we call this hydrogen bonding. Hydrogen bonding is when a hydrogen atom aligns with the negatively charged oxygen in another water molecule. And hydrogen bonds usually occur between hydrogen and oxygen, but it could also be other things like fluorine and chlorine as well. So this can occur between molecules. As it's showing here, we have 5 different water molecules, and they're all doing hydrogen bonding with each other. So we call that intermolecular hydrogen bonding, or it could be intramolecular bonding, which we'll find with things like DNA and proteins, where it's in a single molecule, there's hydrogen bonds happening between the elements. So we're going to learn more about that when we get to protein and DNA, but just keep it in mind for right now that hydrogen bonds are another way that atoms can stick together. And this also leads to many of the properties we associate with water. I just want to show you this little module quick right here, and you guys can explore this too at your leisure. All right. This is going to show us the partial charges in water molecules and how they might be moving around in a solution of water. In this case, we have a 2-dimensional glass of water, if you will. So there aren't water molecules in 3 dimensions, but it'll still give you a good idea. And when I hit the play button here, you'll see that every now and then these will bounce into each other and a little bond will form. And I can click slow motion here, and you'll see all the positive hydrogens when they get close to an oxygen atom that has the partial negative charge, they want to reach out and stick onto it. Okay, so those are hydrogen bonds. It's not quite like a covalent bond in that they're sharing electrons. It's more just that they have opposing charges. All right, and then we can see that as we pump up the temperature here, the molecules are going to move faster. They're less likely to form these bonds. And then if we move the temperature way down, they're going to be a little bit more likely because they aren't moving as quickly. They have less kinetic energy. And then they start all sticking together like this. And we have a term for that. It's called ice. So that's what ice looks like in the at the molecular level. Okay, and again, you guys can use this if you have any more questions. You can go back and look at this. I have it linked in the slides. Okay. So hydrogen bonds lead to lots of different properties in water. This lesson is about the different properties of water. And the biggest thing, or the simplest way to think of it, is it helps hold water together. So we have this property called high latent heat. It's also a solvent. It has the property of adhesion, cohesion, surface tension, capillary action. All of these things are related to what we just learned about today. So in your notes, you're going to write down each of these properties, and then you're going to use the resources that I posted on Moodle to define each one of them. And then tomorrow we'll do a lab exploring them in a little more detail. At this point, your notebook could look something like this. I added on the definition for hydrogen bonds. I added the different properties of water, and then you will go through and put in your own definitions that you find about each one of those. I also drew over here a little diagram. When I'm taking notes in science, I find it quite handy to draw things out because I'm a visual learner. So you can do that as well. And in this case, I drew what a hydrogen bond looks like, where I have the hydrogen atom aligning with the oxygen atom. And then I added another question over here. Which of these properties are due to hydrogen bonding between water molecules? Which ones here do you think are specifically hydrogen bonding between water molecules? I don't know, but maybe I'll find out when I do my research. Okay. So then we started class today with some of these pictures. I posted them at the end. You should be able to, after doing all this, give me an exact reason for why this water strider stays on top of the water. You should be able to tell me how it is that Kool-Aid can hold so much sugar in it. And you should be able to tell me why water forms droplets when it's on a leaf like this. Okay? And then what I want you to do is draw a line at the bottom of your page here and put a summary. About a paragraph is what I'm looking for. We learned a lot of different things today. We learned about hydrogen bonds, we learned about polarity, we learned about the chemical makeup of water. So you should find it pretty easy to write at least 4 sentences in your summary today. If you're out of room in your notebook, you can move to the left-hand side of the page and write your summary there. So I also have one posted here that you can refer to, but I do not just want you to copy this one. Okay, without any further ado, I'll let you guys go get to work. Make sure you get your notes done, and then again, use the resources on the Moodle site to finish up this assignment.